Hi guys, and welcome to this video on an introduction to linear relations, one of a big topic in year 9, and in fact, to be honest with you, huge throughout the rest of maths. If you can get the foundation for this stuff right now and understand that really a linear relation is nothing more than some sort of guessing game in your head or a pattern that you are trying to connect dots to create straight lines, then you will be done. You will be absolutely sorted for the rest of your maths career. So it's actually really important to put time into this now, or this series of videos, to give you some sort of jump start on what is going to happen for the rest of year 9 and year 10, 11 and 12. I promise you, once you start doing graphs and stuff, it never ends. Yeah, like my videos or the sound of my voice. Anyway, my name's Darren, I'm Maths Guru. Thank you very much for joining. Do me a favor if you can you subscribe and let your mates know? That one little click probably, hopefully means nothing to you. That one little subscribe button, nothing to you. To me, it just tells me that people are watching. It is hard creating maths videos. Who wants to watch a maths video? And if you can, leave a comment below and just say, hey, Darren, I watched. It was really good, if you found it really good. If you didn't like it, please don't say anything. Yeah, honestly, it's the whole destroying it hurts me. Cuts to the... Anyway, shut up. What are we doing today? Learning objectives. We're going to learn or understand what a Cartesian plane is, what a coordinate is, and how it's got an x-axis and a y-axis, what it means to be a linear relationship, and understand about x and y intercepts. These are really the foundations for all of the work we're going to do in this module of work. So, you're probably going to turn around and say, I already know what a Cartesian plane is. Okay, maybe you do, maybe you don't. But there we go. Here is what we call a Cartesian plane. And you're going to turn around and say, well, that's just a set of axes. Yes, it is a set of axes. That's exactly what a Cartesian plane is. All right, we have an x-axis, we have a y-axis. So top tip number 1, when you draw a graph, always write on labels on your axes. They're not always x and y. We will try and trick you. Most of the time it is x and y, but not all of the time. Okay, what else have we got here? We have numbered axes, and we notice that the distance between the 0 and the 1 and the 1 and the 2 and the 2 and the 3 are all the same. We have positive values and we have negative values. We have this point in the center here, which is called the origin, which is great in Australia because it's an energy company, which, anyway, that was got to do with it. And then we have these dots with letters beside them, which are coordinates. And hopefully you guys know what a coordinate is. Now, I can't move around on here. If I could, if I had a bigger studio, I'd be great. I'd be running around like a lunatic. But if you remember, coordinates are about going along the corridor and up and down the stairs. And you're like, what on earth is he talking about? I know. Or it has an x value, comma, y value, and a set of brackets. If you write down a coordinate without that comma or without those brackets, sadly, it is wrong. A coordinate is a point in space, and it has a particular way of being written, much like your name. If you miss out a letter on your name, why would you do that? But if you miss out a letter on your name, then obviously you're going to be like, oh, idiot, you missed out. Think the same now with a coordinate. So if we look at the coordinate for B, for example, what is the value? Well, we go from the origin along to the 2 and up 3. So my coordinate is 2, 3. What about J? Well, we're going along 2, but we're going down 2. So that's along 2 and down 2, right? For some reason, my mind now wants to keep drawing 4s, yeah? What about F? Let's look at F, right? So we're back 1 and up none. So F there would be -1, 0. Now, maybe you need to pause the video and just check, but having coordinates or plotting coordinates is important, but it's more important to realize that actually there is a relationship. Yeah, not that type of relationship, between an x value and a y value for things that are on lines. So I'm going to play a game. This is going to be a bit weird because it's not actually going to work. But all right, so I'm going to give, right, you give me a number. Yeah, I actually can't hear you. I really hope you didn't turn around and give me a number. Let's imagine you gave me the number 7. I'm going to give you back the number 15. What's the link? What's the game? What rule have I used in my head to get that, yeah? Now, at the moment, you may not know. You could probably take a guess, and it's not that difficult. But with that one data item, that one piece of information, you don't know. You've got no idea at this moment in time. So I'm going to ask you for another number. Oh, okay, 5. I'm going to give you 11 back. Now, many of you will all be like, yeah, I got the rule, that's fine, thanks very much, know what's going on in your head. You never know what's going on in my head. Other people will need another one. So I'm going to say, give me another number. And you may say 3. And I'm going to say 7. And more of you will get a better idea of what's going on. And all I'm really doing here is just playing a game, and I'm saying, here is your guess, here is my answer, and there is a link between them. And I'm using the same rule always to go from your guess to my answer. Now, some people here may have already said, you know, oh, the rule is +8. It is unlikely in many cases that it's going to be just that simple, but it might have been. Is 5 + 11 8? No, it isn't. So it can't be +8 as my rule. There's got to be some other rule. As it turns out, I'm going to tell you now, the rule was actually I took your guess, I times it by 2, and then I added 1. Right, so I took your guess, I times it by 2 and added 1. That was the rule I was using. That was the relationship, the link between those. Now, normally when I do this with my classes, they are, the numbers they choose. 47, 903. And I play along because I've got to. But I get to a point where I say, guys, let's be sensible here. There is actually a really clever order in which to be able to try and guess these things or come up with patterns, which we're going to do later on. And the first number I would always start with is generally, 0. Now you're going to turn around and say, what's 0 going to tell me? Well, nothing on its own. But the next number I would actually have is 1. And the next number I'd actually would have had was the number 2. And the next number I would have guessed would be the number 3. Because when you have the numbers 0, 1, 2, 3, maybe 4 and 5, the rules become so much easier to work out. And that's a bit of a trick that's coming up later on. Right? So if I have my number 0, 1, 2, 3, and 4, and I'm going to follow through with my game again, then I would have had 1, 3, 5, 7, and 9. Those would have been my guesses. So my rule was times by 2 plus 1. And sort of to shortcut to a little bit of a later video, I want you to try and see what is the distance, or what is the gap? What am I adding each time to get between each of these numbers? And if you turn around and say 2, congratulations. You can do that. But I also want you to start thinking about, why is that a 2, right? So these are all things that are coming on. That's why this is an introduction. But what I want to say now is that actually, why on earth would I in maths use the words your guess and my answer? I wonder if there is another way of being able to do this. Well, absolutely. We're lazy mathematicians, right? We want to come up with a relationship. And we're going to use letters. So generally speaking, my answer is always going to be the letter Y. Well, for now. And your guess I'm going to call X. And you're going to turn around and say, well, couldn't we have chosen better numbers? We could. But go back to your axes. What do you notice about the axes labels, X and Y? What if all of these X values I thought of as your guess? And I could turn those into Y values that would then show me some sort of a relationship. So writing this out in a different way then, so as I say here, we can write that out as Y equals X times 2 plus 3. All I've taken is the times by 2 is copied down, the plus 3 is copied down, and because we know by the time we get to year 9 that X times 2 can be written as 2X, we can rethink the game I was playing as Y is equal to 2X plus 3. And you're going to say, what? Read it for what it is. To find the value of Y, I am going to take my value of X, double it, and add 3. Okay, so that was maybe a different game. I've just realized that I did a different game in my head than this one here. Now, relationships, X's and Y's, patterns, the whole thing for linear relationships. So let's now look at me as if I was playing Y equals X plus 2. Now, that means that my guess is going to be your number plus 2. So writing out a table of values here, and thank you so much to Cambridge for allowing me to use their examples in my videos. You guys are so great. Thank you so very much. But if we look at this here, I have chosen definitely the values 0, 1, 2, and 3, but I've also thrown some negative values in there as well. I've thrown in -3, -2, -1, because if we look at axes, they go both positive and they go negative. So actually having some negative numbers is really helpful. Now, what did we decide? X is effectively your number and Y is my guess. So it said my guess was your number plus 2. So let's just check. I've got 0 here. Here's my 0 value. If I add 2, do I get 2? I do. So if the top number is 1, 1 plus 2 is 3. 2 plus 2 is 4. And there we go. So again, if I draw this out in a slightly simpler way, there's 0, there's 1, there's 2. So there's my value of X, there's my value of Y. That became 2, 3, and 4. Do you see a pattern forming here? Absolutely. So if I've got minus 1, minus 2, then I must know that that's 1, and that must be 0, because each of these is either going up by 1, or it's going down by 1. So those patterns can actually help us as well. And why is this important to us? Because the whole work we're doing on linear relationships takes these tables, these your number and my guess, and place them on a Cartesian plane. So if we look then, that these things here, because we've got x's and y's, these are basically just coordinates. So although we've written it as 0 with the 2 below, that's actually exactly the same as a coordinate 0, 2. And where is the coordinate 0, 2? 0, 2 is that green and now red dot there. Let's take the next coordinate, 1 and 3. So 1 across and 3 up and do a dot. The next one, 2, 4. 2 across, 4 up. There's my dot. 3 across, 5 up. There's my dot. Now actually, in many cases, as I've just taught my year 11s, we only need 3 or 4 dots to be able to help us finish our straight line. And because we notice that all of those now are in a line, they are part of a line ER relation. No, we don't say line ER. Linear. Oh my goodness, look, linear has the word line in it. And relationship just means they're cuddling. No, they're not cuddling. So what I'm now going to do is connect all of these points together with a straight line. And you're going to turn around and go, well, it wasn't very straight. And I'm going to turn around and say, no, it really, really wasn't. But you're going to do it with a ruler. I was expecting my computer actually to make that go straight, but PowerPoint doesn't. Now, words of advice. Arrows on the ends of the lines. Yes? Why? Well, you've only drawn a little bit of that line. That line, like my hero, Buzz Lightyear, goes on to infinity and beyond. Okay? So if it goes on to infinity and beyond, we have to tell the examiner, oh, I know, it's just a little bit. I should put arrows on here and a Y, and an arrow on here and an X. And whenever we draw these things, we should always put the equation of the line on. So Y equals X plus 2. Now, if you haven't understood this or want to watch it again, you can. It's a video. Go back, play this bit again, see whether you can work out why. Firstly, where did we get this table of values from? Secondly, how did I take that table of values and turn it into a graph? And then having drawn all those dots in, how did I know it was a linear relationship? Because if you know the answers to those 3 questions, the rest of it, you are going to be guns out. So here's a different rule. The rule is y equals minus 2x plus 2. Now what does that mean? It means that the number I'm going to give back to you on my y coordinate is the value that we're given, your guess if you want, or the values in the table. We're going to times it by 2, and then we're going to add 2 to the result. Now I've already done the table for you, but let's just check. Now we start with 0 because 0 is a great number and it's the name of my dog. Anyway, so to find the y value, I'm going to do minus 2 times my x value. The x value that was given to me is 0. And I'm going to add 2. So minus 2 times 0, well, anything times 0 is 0. Plus 2 is 2, and that's where I got my 2 from. If we now look at 1, what do we notice? We get y is equal to minus 2 times 1 plus 2. Well, minus 2 times 1 is minus 2, plus 2 gives me 0. So for an x value of 1, my y value comes out as 0. And I can keep repeating that over and over again until my table's full. But again, what do you notice? The values as we go through here subtracting 2 if we read from left to right, or adding 2 if you read from right to left. These are coordinates, so let's just check. Taking this one here, that's 0, 2. 0 across, 2 up, there is my coordinate point. What's that next one? 1 across, 0 up, there it is. 2 across, 2 down, there it is. And having got 3 or 4 points, I can then join this together. And again, I'm so sorry guys, I can't do this accurately. You will have to do it. There's my arrows. I'd put a y on there, I'd put an x on there, and the equation of my line would be y equals minus 2x plus 2. Do all of that in an exam and you could get up to 3 or 4 marks. 1 for the axes, 1 for the straight line, 1 for labeling the graph, and obviously 1 because we like you. Come on, you're amazing. Right, so again, this is an introduction. We're going to do more of this a lot later. Intercepts. Now, an intercept is where things cross. If I look at this graph here, if I again try and draw this with as straight a line as I possibly can, we notice that it crosses axes. It crosses my y-axis here, and it crosses my x-axis here. And where it crosses either the y-axis or the x-axis, we call it an intercept. So that point there is my y-axis intercept. Now again, you can download these from mathsguru.com. If you go there, sign up, free to sign up, watch this video, the notes will be there and downloadable, all right? So I'm trying to get it so you can download them, copy them into your summary book, and life is good. This one here crosses the x-axis. Remember, this is the x-axis, this is my y-axis, so that is my x-axis intercept. Knowing those points actually later on in another video is going to make life really, really easy for you. All right, so again, what is this point here? A lot of people go, it's 2, and I go, no. An x-axis or y-axis intercept is a coordinate. So that one there, we'd actually have to write down as 0, 2. All right, it's none across, 2 up. This one here is not minus 2, it is minus 2, 0. So if ever a question said you write down the intercepts, you'd be expected to write down a coordinate. And again, here is another example. If I try and draw these together in a straight line, you'll notice that that previous one, the line seemed to slope up. This one seems to slope down. That's going to come up again later on. So what do we notice here? Well, we've got some sort of a rule. We've already taken our table and plotted our coordinates. Where are our intercepts? Well, where it crosses the y-axis is there, it crosses the x-axis there, and can we read off those coordinate points? That is 0, 2, and that one there is 1, 0. Now, what I want to try and give you a bit of a hint for later on is, again, look at these 2 points here. What do you notice? There is a 0 here, and there is a 0 here. And actually, they are your intercepts. You just need to be a bit careful because a lot of people think that because that's in the x, it's the x-axis intercept. It isn't, it's the y-axis. But again, we're coming back to that a little bit later on. So here we go. Finding an intercept from a table of values. Here is a table of values. Can you find the x and y-axis intercept? Well, actually, I gave you the bit of a hint earlier. Remember, if we were to plot this graph, we would have 0, 2. We would have 1, 0, and all those other points. But we know that that point there and that point there are my x and y-axis intercepts. So anything that has a 0 in the table is going to be probably an intercept. No, I'm trying to think, yep, it will be an intercept. So we know here that we can write that as a coordinate, that is 0, 2. We know we can write that as a coordinate, which is 1, 0. And all you need to do is be able to say which one is the x-axis intercept and which one is the y-axis intercept. Well, if the x value is 0, that there must be the y-axis intercept, which means that automatically becomes the x-axis intercept. Happy with that? All right. Alternatively, I say, well, the x is 0, so it must be the y. It's the opposite to what it is. Can we do this from a graph? Yeah, from a graph? Oh, I should think so. We don't need a table. They've given us the 2 points we need here. We're noticing that they happen to cross there. So that there, if I read off the coordinate, is 0, 6. That one there is minus 4 comma 0. And so therefore, I could write down that that there is my y-intercept, and that one there is my x-intercept. God, they say this stuff is hard. All right, so the rule of these things is really the key to understanding. I know this has been a long video, and I do thank you if you're still watching it. You are going to smash this rest of this course. But we have a question, all right? Now, the rule tells us where the points are on the line. What you've noticed up until now is that where I have a straight line, all of the points on here are joined by the same rule. If I put an x value in to my rule, it gives me a y value out. But what if they give me a point and say, does that sit on the line? Well, we know that a coordinate is given by an x value and a y value. So I'm now going to say, well, if this point is on that line, when I put the minus 2 into my equation, I should get 4 out. So let's see. So we've got y is equal to 2. I'm going to let x be minus 2. And I'm going to do plus 10. So my y value comes out to be 2 times minus 2 is minus 4 plus 10. So y would be equal to 6. Was y equal to 6 in my question? No. And rubbing up the working out that was already there, what did we notice? The y value was actually 4. So we are saying that if I put minus 2 into that equation there, I would have 6 come out. That line there would, or that point there, sorry, would sit on the line. The point minus 2, 4 does not sit on the line. What about this one? Same working out, same idea. Does the point minus 2 comma 4 sit on the line of y equals minus x plus 2? Well, let's take the x value and see what happens. Y is equal to minus 2. Lots of people made a mistake on this question here because they forgot to put the minus and the minus. Plus 2. Let's see. So minus 2 is 2 plus 2. Y comes out to be 4. Were we expecting y to be 4? It was. So in this particular equation, with that point, it would sit on the line. Now, finding rules from tables of values is also really, really important. And I said to you a little bit earlier in the video, can you do this? Well, hopefully you can. He says, just trying to see how long this video already is, 23 minutes. Again, thank you if you're watching. So what do we got here? To do this, we need to look. What did you notice about the change here? The change here, they seem to all go up in ones. Now, the first trick to this is, this rule thing only works if all of these numbers here go up in ones. Later on, I'll show you other ways of doing it. But if the top all go up in ones and the bottoms all go up in ones, then we always know that our rule starts with a y equals and it has an x in it. And I said to you previously that there is actually a link between the number that these go up and the number in front of the x. And because they all go up in ones, that becomes 1x. So we now have a rule that says y equals x, but we've got to find out, is there any other number here? So let's have a look. Y equals x. So x is 0 here. That would mean if y equals x, that would be 0. That's not 0, it's 2. Y equals x, we've got 1, I want 3. I've got 2, I want 4. Can you see what's happening in each case? Absolutely. If I take the x value and then add 2, I get each of the y values. So I could write y equals 1x plus 2, but we know that we actually write that as x plus 2. And there is my rule. Now, again, there are tricks to all of this. So we'll look at this one here. First question always is, are the top numbers going up in ones? They are. Awesome. Now let's look at the rule. Let's look at the difference between each of these numbers. What do we notice? They are each plus 2. They're going up by 2. So I now know my rule. All rules start with y equals. The difference in those numbers is 2x. So we've now got 2x. We've got to find this missing number here. So I'm going to take my x value. Let's take my x value here of 0. I'm going to double it. Is 0. Have I got 0? We have. But you have to test more than one value. I've got an x value of 1. So 2x would be 2. Is that what I need? It is. So in which case, that's actually plus 0. But we don't write plus 0. So the rule for that one was nice and easy. Y equals 2x. here's the trick. Are the top numbers going up in ones? They're not. So what do we do here? Well, we could add the middle numbers. That could be 2, 3, 4, 6, and 8. And what we notice is that's going up by 1 for every 2 numbers. It's going up by 1 for every 2 numbers. So that must mean that that number there would be 1.5 because it's going up by a half on the bottom. That would be 2.5. So having now got my numbers 1, 2, 3, 4, and 1, 1.5, 2, 2.5, etc. What are these going up in? They're going up in halves. So my rule would be y equals 1/2 of x, and we just got to find this bit here. So I take my x value and I halve it. What's half of 1? It's a half. But I need 1. So I'm going to now write here plus a half and see what happens. I've got my 3. What's half of 3? 1.5. If I add a half, do I get 2? I absolutely do. And there we go. We get y is equal to, so my final formula would y equals 1/2 x plus a half. Whew. Now you're going to say this is really hard. It gets a little bit tricky, but again, there are other ways to do this. Sometimes teachers turn around and go, well, if I look at my top column of my table, I've got the numbers 1 and 3 and 1 and 2. So that's my x and that's my y. And later on, you're going to find out that this number here, which actually stands for the gradient of the line, is a change in height over a change in run. So if I look at this here, this change, that horizontal change is 2, and that vertical change is 1, and that's actually where we get the half from. So again, more on this a little bit later on. But that's pretty much the end of the video. Thank you so much. Again, if you need to, watch it again. Watch bits of it again, but I will recap it in later videos. Thank you very much for subscribing if you have. Thank you for leaving a comment if you have. Thank you for telling your mates if you have. Otherwise, I'm going to call it a day. Stay safe. Look after yourself. I look forward to seeing you in another video. Take care. Bye-bye.